So the first operation is multiplying rational expressions. Okay, the product of two rational expressions. So we have one real expression, rational expression here and another here, is defined as p of x over q of x times r of x as over t of x. Okay, in rational numbers, we were going to multiply the numerators and denominators one by one. Okay, in expressions also we do the same. It means numerator times the numerator, p of x times r of x, and denominator times denominator, q of x times t of x. When multiplying rational expressions, we always simplify the product if possible. It means after multiplying, if we had a common factor of, or if it is factorizable, then we factor, and after that we simplify it. Okay, look, for example, x plus 2 over x minus 2 times x plus 5 over x minus 1. We have what? We have two rational expressions. One is here, another is here. So we are going to multiply the numerators and denominators. Okay, x plus 2 times x plus 5, and at the denominator we have x minus 2 times x minus 1. So we don't have any specific common factor, or we cannot simplify it. Okay, so for better understanding, let's practice some exercises. Here are some more examples of multiplying rational expressions. Okay, look, we have two rational expressions. Okay, the first step that we should go through is to write them at the one fractions. So 10 x squared times y. Okay, this is the first one. The second one is 4a squared. Am I right? At denominator we have 8a times b cubed times 2x y cubed. So we can simplify these expressions because we have common factors. Look, we have a squared here, we have a here. We can easily simplify it. Okay, let me write each of the expressions to its factors. It means we can write 10 as 5 times 2. Okay, x squared is x times x, y itself, times 4. We can write 2 times 2, and also we have a squared. It means a times a. At the denominator we have 8. Can we write like 4 times 2 times a times what? B cubed. We are going to write itself because we don't have any b at the numerator to cancel it. Okay, and also 2 times x times y to the power of 2 times y. This is y to the power of 3. Okay, and here also we have y to the power of 3. Okay, we have to cancel them. 2 with 2 goes with 2. Another 2 with this 2. Am I right? Okay, we have 2 here, and we have 4. 4 is equal to 2 times 2. We can cancel 1 2 with this 2. It means instead of 4, we wrote 2 times 2. Okay, we have x here. X goes with x. Okay, what else? A goes with a. Another, we have y. Y goes with this y. At the denominator we will just have y squared. Okay, another else? Nothing else. Am I right? Okay, so we have x, we have 5, we have a. So 5xa from the numerator, and also we have 2 and b cubed, and also y squared. So we can write it at the denominators. 2b cubed, what? And also y squared. So we don't have any common factors to cancel them or simplify it. Okay, look at the second questions. xy minus 1 over xy plus y. And also this expressions. So first step we should go through is to write it in a big fractions. xy minus 1. Am I right? Okay. Times. Look, 2yx squared plus 4xy plus 2y. So what should we take as a common factor in your perspective, in your opinion? What's the common factor from here? We should take the greatest common factor. Greatest common factor of what? 2yx squared, 4xy, and also 2y. So, what's the greatest common factor? We have studied at the previous lesson. We should take the number and the variable which has lowest degree. So, we have 2y here, we have 4xy. At the last term, we don't have any x. So we don't have any x, so we cannot take it as a greatest common factor. We can take 2y because 2y is simplifiable or divisible by each of them, okay? So we take 2y as a factor. 2yx squared divided by 2y is equal to x squared. Am I right? 4xy divided by 2y is equal to 2x. 2y divided by 2y is equal to 1. Okay. And here, also greatest common factor of xy and y. What's the greatest common factor? In here it was 2y, and here should be y. If we take it as a factor. xy divided by y is equal to x plus y divided by y is equal to 1. So, in here, also we should take the greatest common factor of x squared y and also xy. Okay? Let me show you how to how to factorize the denominator. In here, xy is the common factor, the greatest common factor. So we take xy as a factor. Sorry, small parenthesis. xy. X squared y divided by xy is equal to what? Is equal to x. Am I right? Plus xy divided by xy is equal to 1. So this is the factorization of this expression, okay? And here we have minus x minus y, minus 1. Okay, if we take minus as a factor, so in here it will be equal to what? X plus 1. Am I right? If you again multiply this minus with each term, the answer will be this, okay? So it doesn't matter. So in here we have a big expressions. We have studied from identities. X plus 1 square is equal to x squared plus 2x plus 1. So instead of this, we can write like x plus 1 squared xy minus 1 times 2y times x plus 1 squared, x plus 1 squared. From the denominator, we have y, we have x plus 1, we have xy times x plus 1, and also minus x plus 1. Am I right? Okay, so we can easily simplify it. Y goes with this y. Okay. What else? Okay, in here we can also simplify or factorize it. X plus 1. If we simplify it, we can write like this. xy minus 1. Because in this expression, look, we have x plus 1 minus x plus 1. If we take x plus 1 as a factor, okay, x plus 1 times xy minus this, okay? So we can cancel x minus 1 with this x minus 1. We have 2x plus 1 squared, and also in the denominator we have x plus 1 times x plus 1. It means we can cancel them, okay? So the answer will be 2. Did you understand? Okay. Another operations is dividing rational expressions. Okay, the quotient of two rational expressions px over q of x and r of x over t of x is defined as p of x over q of x when divided by r of x over t of x is equal to p of x over q of x times t of x over r of x. This was like what? The division of algebraic expressions in what? In fractions. It means if there's 1 over 2 divided by 2 over 3, okay, the first fraction itself, we have to inverse, okay, inverse the second, what? The second fraction, and this operation signs change to multiplication, okay? It means p of x times what? T of x, and q of x times r of x, where q of x and t of x, which are the denominators, doesn't equals to 0. Look, for example, 5x squared over 4y cubed divided by 4x over 3y squared. Okay, look, the first fraction itself, and we have to what? Change or switch the position of numerator and denominator of the second fraction. So this operation changes to multiplication. So we will go what? Like multiplication of algebraic rational expressions. Am I right? So numerators and denominators, 5x squared times 3y squared and 4y cubed times 4x. If it's simplifiable, we can simplify it. 5 times 3, 15. Okay? X squared, x times x, and also y squared in here. We have a denominator 4 times 4, 16. X and y times y squared is equal to y cubed. Am I right? Y times y squared. Okay, at the denominator we also have y squared, then we can cancel them. Two common factors, x and x, we can simplify them. Okay, what left? 15 over 16. At the 1x from the numerator and 1y from the denominator. Okay, 15x plus 16y is the answer. Look at some more examples. 6a squared b over 10xy divided by 12ab cubed over 4x squared. Okay, 6a squared b, 10xy, the first fraction itself. This operation changes to multiplication. Am I right? And we have to switch the position of numerator and denominator. It means 4x squared over 12ab cubed. Am I right? Okay, we have to write them at one fractions. It means we have to multiply them. Okay, 6a squared b times 4x squared over 10xy times 12ab cubed. Okay, can we simplify them? Yes. We have a squared, we have a. This a goes with 1a here. Okay, we have b and b cubed. We can cancel them. And here, just b squared. 1b goes with the numerator. Okay, 4. Look, 1 times 4, 4. 3 times 4, 12. Am I right? 1 times 3, 3. 2 times 3, 6. Am I right? Okay, we have a here. B went with this b. So we have 1x here and 1x here. Just 1x left from the numerator. So, okay, 1, 2, 2. 5 times 2 is equal to 10. So, what's the answer? We have a. Am I right? We have x here. And also 5 times y times what? B squared. Okay, did you understand? Okay, let me go through the second questions. We have x squared minus 100, 8 squared minus b squared, okay? Divided by 3x plus 30 over a plus b. So, look, we have x squared minus 100. Did you understand that we have studied how to expand the binomial of a to the power of n minus b to the power of n? Can we write this x squared minus 10 squared. Okay, we can expand it like x minus 10 and also x plus 10. And also a squared minus b squared. Okay, this was the expansion. Okay, this was the binomial. Okay, and here we have a squared minus b squared. Also, we can expand it like this: a minus b times a plus b. We have studied in the identities. Okay, if you don't remember, just watch the previous videos. Okay, x squared minus 100 is equal to x minus 10 times x plus 10, and also at the denominator a squared minus b squared is equal to a minus b times a plus b. Okay, then we are going to write them down: x minus 10 times x plus 10 over a minus b times a plus b. This sign changes to multiplication, and after that 3x plus 30. If we factor 3, the answer will be x plus 10. Okay, 3 times x, 3x, 3 times 10 is equal to 30. We just factored 3. Okay, at the denominator we have a plus b. Okay, let me write here because it shouldn't be confused. Okay, then we are going to write them. Okay, write them at the one fraction. It means x minus 10 times x plus 10 times 3 times x plus what? Sorry, we have to switch the positions. Am I right? Then we should write a plus b to the numerator. It should be to the numerator, and it should be go to denominator. A plus b here. At the denominator we have 3 times x plus what? 10. Am I right? Okay, and also we had a minus b times a plus b. A minus b. Okay, we can write here a plus b. Doesn't matter. Then we can easily simplify that. X plus 10 goes with x plus 10. A plus b goes with a plus b. So we have x minus 10 over 3 times a minus b. 3 times a minus b. This a minus b and this a plus b is from the first fraction here. Okay? X minus 10 and x plus 10 is from the here. And also 3x plus 10, because we switch the position of the numerator and denominator, it went to the denominator, and this a plus b is here, the denominator of the second fraction. A plus b with a plus b went cancelled, x plus 10 with x plus 10 cancelled, x minus 10 left, and from the denominator we had 3 and a minus b. Okay, thanks dear students. This was the operation on rational expressions. If you have any suggestion or a comment, just write it below. Thanks for watching.